All right, everyone, let's take a look at the parallel circuit worksheet here. We'll go down through these one by one. Let's start out with question one on here. All right, and so here it looks like we're going to be trying to solve for the current in here. What I try to tell everyone is to uh, label your items that are given to us. So I like to put in here what we're dealing with. We've got 12 volts. We don't know the current. Um, and then our resistors here for R1 are 4 ohms and 4 ohms. All right, so there's really two ways of handling this. One is we could just apply the simple rule when we have loads in a circuit that are of equal resistance, we can divide it by the number of branches. So in this case, we have 4 ohms on both loads. If we were to take 4 ohms and we were to divide it by the two branches, we would end up with a resistance equivalency of a resistance total, in this case, same thing, of 2 ohms. However, I think that it's often better to do this mathematically to avoid any errors that might occur. And also the fact that very often um, we won't be dealing with circuits that have just two equal loads. So let's just write this out. So the very first thing we're going to want to do, let's take a look for resistance equivalency or resistance total in this case for this circuit. So we would write our parallel circuit, which is 1 over RT is equal to 1 over R1 plus 1 over R2. And from here, we can just go ahead and plug our numbers in. 1 over 4, 1 over 4. And that would end up being 2 fourths, which is what, 1/2 when we reduce it. Then we do the inverse of this. And then that would end up being our resistance total in this case is 2 ohms. Same number that we got before. Um, just that this is the, I guess, mathematical way of um, determining that. So let me just highlight that so we have it to look at later if we need to. Okay, so we got resistance total. So now, once we know that, we just go back to Ohm's law and use that formula. So we're trying to solve for current. So current is equal to voltage divided by resistance. And so in this case, we've got 12 divided by 2. So our current is equal to 6 amps. And highlight that one again for us. So we got, so this guy we could write in over here. Oop, sorry, highlighter. Here we can write this in as 6 amps. And then I like to put that in here, label things, right? We got 6 amps and then coming up and then back 6 amps. So that's pretty good. And we can check ourselves, right, to make sure that that works by using, again, Ohm's law. So over here, I might write something like voltage is equal to amps times current. Uh, that's not right. Amps times current. Amps times resistance. Sorry about that. And then this becomes 6 times 2. That's our total. And then that's 12. So once we see that our voltage is 12, and that matches what we've got listed as a given, that we got voltage is 12. So that's good. Now, the other thing that we might want to do, looking at the circuit, is we might want to determine at this point and at this point what how much current is going down each one of these branches. So I like to try to just label. I'm going to put B1 for branch 1 and then branch 2 here. Also, we know that there's 12 volts at both of these points. And we know down here that there will be 0 volts, right? Because the voltage drop will be the same, right, on both of these ends. So if we wanted to determine, if I said, hey, what's the current that flows through branch 1, or what's the current that flows through branch 2? Some of you might say, well, that's easy. They each have the same resistance, so whatever the amperage is going to have an equal amount. And you'd be right? We'd have about 3 amps. Well, let's prove that mathematically. So in order to determine that, right, for branch 1, if I wanted to determine current flow, right, I would write that maybe like current of branch 1, right, is equal to the voltage divided by the resistance. And so current here would be 12, or voltage is 12, and then we divide it by 4. And so B1 is equal to 3 amps. And we can do the same thing for branch 2 here. Just like this is the same exact numbers. We got the same exact figures here because we got equal resistances. This will change later on. That's why it's good, I think, to just practice from the start writing out this formula. So what this is saying to me is that, hey, we got 3 amps flowing through this one and 3 amps flowing through this branch 2. And then coming back here, right, we always have, in our case of parallel circuits, the sum of our currents, right, comes back is equal to our total current. We got 3 amps and 3 amps, okay? So that should pretty much solve everything for question 1. Let's go ahead and move on to question 2. Okay, so here for question 2, let's go ahead and plug in our same number values, which I like to do. So I had 12 volts here, that in there, and then our R1 is 6 ohms, and R2 we don't know. And then for this one, we're saying that the current comes out here is what, 4 amps, and then what's coming back is 4 amps, like so, right? So now, based on that, let's see if we can figure out what's going on here. So these are sometimes, in my opinion, of the 3 different ones we're going to do, the most challenging when we're trying to solve for an unknown resistor in a parallel circuit. So the first thing that we want to do is, based on what's been given to us, we can solve for resistance because we've been given amperage and voltage. But when I say resistance, I mean resistance total. So let me write that out. So resistance total is going to be equal to voltage over amperage. And so if I solve that, that would be 12 divided by 4. So my resistance total in this circuit, right, is 3 ohms. Now, once I know that, I can now use Ohm's law and try to solve this whole unit. So let's take a look. So if I went 1 over RT is equal to 1 over R1 plus 1 over R2, which is our parallel circuit formula. And I plug in my knowns. Now I know resistance total, we just said, is 3. R1 in this case is 6. And R2, we don't know. That's the one we're trying to solve for. Okay. So once I have the equation written like this, I want to try to get things situated. What I would recommend doing is switching and getting my variable on the left-hand side. So I can rewrite this formula very simply like this. Right, same exact thing. Then I'm going to subtract 1/6 from this side and subtract 1/6 from this side to give me 1/3 minus 1/6. Now I need to have a common denominator, right? To make this work. So 6, both 3 and 6 will go into 6. 3 goes in twice, and 6 stays the same because it only goes in once. And so RT is equal now to 1/6, right? And then I'm going to rewrite this up here so you can see it without me making it too tight. Just going to rewrite that here. Now I need to do the inverse to both sides. So I flip these over. R2 over 1 is equal to 6 over 1, or R2 is equal to 6 ohms. So now over here, I know that this is 6 ohms. So I can write this in here. Okay. And now if I want to double check my work, I most certainly can. So I might go voltage. I like this one because it's always I don't know, the easiest for me. So I write in there voltage, and then my current now, I've got it 4. And then again, this is resistance. So it's not both resistors, it's resistance total, which for us was 3. And so my voltage is 12 volts. So that works out. Okay. Next, again, I'm not gonna make this an overly long video, but if I wanted to figure out my amperages through each of these branches here, right? I know that these are 12 volts, and 12 volts. And current would be equal to voltage divided by resistance. So that means that each one of these branches, 12 divided by 6 would be 2, have 2 amps through it. Okay. And you can look back at the first equation where I showed you how to solve for that. All right, let's take a look at number 3. All right, so for number 3 here again, just going to go in and put my same items in here. So I got 12 volts here. I don't know current in this case. Resistors 1 are 12 ohms and 12 ohms. Um, so in order to solve this one, I got to figure out my resistance total. You could use the easy formula, which would be the 12 ohms divided by the number of branches, which would be 2, and be 6 ohms. However, I'm trying to show you the way to work these problems with the equation. So let's take a look here. 1 over RT is equal to 1 over R1 plus 1 over R2. So in this case, I will plug my numbers in. So for this one, I got 12 plus 12. Since I have the same denominator, it makes it a bit easier than normal, right? So this would be 2 12s. And then the inverse of these. And I'm kind of showing you, I normally wouldn't write this completely out because I know that I would just flip it over, but R2 in this case is going to be equal to 6 ohms. So over here, I'm sorry, my total is, yeah, total resistance for this 6 ohms, right? I meant to put T here, and I don't know why I wrote it 2. Sorry about that. I'm not trying to confuse you. I was writing along. So right here, right, should be RT is equal to 6 ohms. Sorry about that. All right, so now once I know that, now I can solve for what I'm ultimately going after using Ohm's law. So my current is equal to voltage divided by resistance, or RT. So in this case, IT is equal to 12 divided by 6, which means that my current is 2 amps. 2 amps coming out of that battery, 2 amps coming back to it. Now, if I want to solve for the branch currents, just like we've done before, right? We know we've got 12 here in this case, 0 down here. That's the voltage drop. And so if we wanted to solve for that, it would be as simple as going, okay, current, and I use B1 for my branch 1, just for my own mental sanity. Okay, and so this would be what voltage times resistance. No, divided by resistance for Ohm's law, which would be 12 divided by 12 or 1 amp, right? And it would be the same for each side, which makes sense, right? We got 1 amp flowing this way, got 1 amp flowing through this branch, and then 1 amp coming through that load, and 1 amp coming back. And we add those two together, you end up with 2 amps. So that all makes sense. Very good. All right, let's take a look at number 4. All right, so for number 4, we've added another branch. So at first, this may seem a bit intimidating, but it really is the same that we've been discussing. So let's take a look here. First thing I like to do, put my voltage in there. That's what's given to us. We don't know the current. R1 is 4 ohms, R2 is 4 ohms, and R3 is 2 ohms. And so we're going to be trying to solve for current in this case. So we need to figure out what our resistance equivalency is. So we're going to start with our formula, RT equal to 1 over R1, 1 over R2, and 1 over R3. So resistance total is equal to 1 over 4 over 4 and 1 over 2. Now, what will 4 and 2 both go into? Yeah, they'll both go into 4. So we don't really have to change anything here. Those two are the same. Change this one to 4, and 2 goes into 4 twice. So that becomes 2 over 4. And then that becomes what? Oh, 4 over 4. It's going to be 1. So the reciprocal of this, RT, is 1 ohm. Okay. So now once we know that, we can go back to Ohm's law and we'll write out the total current is equal to voltage divided by resistance. In this case, we've got 12 volts divided by our resistance total, right, which was 1. So our current in this is going to be 12 amps. And then I can go over here and label that in there, 12 amps. 12 amps, right? And now we got 3 different branches. Now these branches aren't the same. So it probably is worthwhile to go in there and determine current flows through each of these branches. So in other words, how much is flowing through this guy, right? And then how much is coming through this guy, and then how much through this, right? And as we're studying parallel circuits, it just helps validate our answers because um, we know that whatever current's coming out has to go back. So let's take a look. We'll take a look here. R1, um, current branch. I'm going to go current through R1 is equal to voltage divided by resistance. R1 is going to be what? 12 divided by a resistance here, which is 4. So this one has 3 amps. And then here we've got for resistance 2, which is going to be 12 divided by 4, 3 amps. So that seems those are the same resistances. We should expect the same flow through there. But the last one has 2 ohms, and that's kind of an important thing to kind of be mentally thinking about. So that's less resistance, which means we should expect higher current. Um, and so let's just do the math on that guy so that we get this figured out. IR3 is equal to voltage divided by resistance. Put this in here, 12 divided by 2. And so IR3 is 6 amps, right? And then if you take a look at something here that makes this helpful, these guys right here, right? If we were to add those values together, 3 plus 3 plus 6, we get 12. And if you take a look up here, we had 12 amps. So that makes sense, right? That matches everything. So you feel pretty confident that our numbers here are making sense for all of this. So I'm going to put 3 amps in here, 3 amps in here, and then 6 amps. So same thing all the way around this. And it's kind of neat because you get a really good visual of what's going on. All right, let's take a look at number 5. Okay, for question 5 here, we've got something similar, but we're going to be solving for voltage. So I'm going to go in here again, put in what I do know. So we've got 12 amps. And then we got, let's see, R1 is 2 ohms, R2, 4 ohms, and R3 is 4 ohms. Okay, so this one, we'll start out with figuring out our resistance total or equivalent for this one. And let's plug our numbers in here. There we go. And then this will end up being 1, right? For our resistance total. And then from there, now we can use Ohm's law is equal to current times resistance. And we got 12 amps. So our voltage in this case is 12 volts. Like so. And then as we were discussing earlier, we could put in our branches here, right? B1, B2, and B3. And if we want to figure out our current on those, right? So is equal to voltage divided by resistance, which is going to be 12 divided by 2. Current through that first branch is going to be 6 amps. And then if we do the same thing, sorry, I made a little boo-boo there. Put the transferred the wrong thing. This should be R1. And this one will be R2. Again, same thing. And IR2 is equal to 12 divided by 4. So IR2 is equal to 3 amps. And then IR3 will have the same thing, right? Same voltage and same resistance. So we could pencil in here now at this point here that we've got 6 amps. And then this one is 3 amps, 3 amps. And this one's got 6. Okay. And that should pretty much wrap up question 5 right there. Got all of our solutions. So let's take a look at number 6. Okay, and here is number 6. So again, I'm just going to go around and label like I have been, but I can. Current in this one is 12 amps. We got 4 ohms. We don't know what R2 is, and R3 is 2 ohms. All right, and I think I mentioned this before, but I find the most challenging ones the ones that are looking for the missing resistance. So the first thing I'm going to do here is I'm going to have to solve for what the resistance total is because I have voltage and amperage, right? So resistance total would be equal to voltage divided by amps in this case, which will be 12 divided by 12, or it looks like, oh, total resistance of 1 ohm, right? So interesting. So now, if I want to figure this out using my formula, right? Resistance total is equal to R1 plus R2 plus R3. So my resistance total is going to be 1 over 1 is equal to 1 over 4 plus 1 over, well, we don't know, R2, and then 1 over 2. And so 1 goes into 1 once, so we can just do that, simplify that easily. Here on this side, we're going to want to flip things around a little bit. So I think what I would do, let me back up here a minute. What I would do is I would rewrite this equation. I think it becomes easier um, when we get the variable on the left side. You don't have to do this, but it'll end up working out better in the end because you're going to have to flip it, I think, anyways. And then R3, I put the wrong number in here. R3 was 2. Just like that, right? Same equation, just flipping it left to right and so forth. So then we got 1 over R2 is equal to 1 over, no, equal plus subtract 1/4 and 1/2 from each side. Let's write that out again. Just gonna keep it all as fractions for right now. I know we could reduce, but you'll see why here. And then the question is, what is a common denominator? And of course, it would be 4. So you get 4 over 4, 1 over 4, and then 2 over 4. And that's what? 4 minus 1 is 3. 3 minus 2 is 1. So you end up with 1/4. Then the reciprocal of that becomes R2 is equal to 4. 4 what? 4 ohms. Up here, 4 ohms. You now write that in there, 4 ohms. Okay. And then if we want to determine again current for these branches, that is equal to voltage divided by resistance for IR1. This one, IR2, will be the same. 1, 12. We have 4 in this one. And IR2, we have 12. And we have 4 in that one as well. So IR1 is 3 amps and IR2 is 3 amps. And then let's look at IR3 would be equal to the same thing, right? Voltage, sorry. Um, Over there we have 2. So IR3 is 6 amps, right? So now we've got coming down this way and this way. And this way we have uh, 3 amps, 3 amps, and 6 amps, which means coming out this side out of these branches is going to be the same, right? 3 amps, 3 amps, and 6 amps. If we add those together, we get 12 amps, which is what we were given. So in this case, looks like we've got this equation all solved for worksheet one. So hopefully you found that helpful. If you got any questions, please let me know. Try to clarify anything that I may have missed or skipped on you. Thanks for watching.